There are many intriguing things in deep space, and one of them is wormholes. For many years, scientists have speculated and researched wormholes, but they have now finally found the first ever wormhole. What is a wormhole? Why are astronomers so excited about it? And how does the discovery affect you as a person? In this video, we bring you the first ever wormhole discovered by scientists. Many humans may not know how much work the Earth does in protecting us. Thanks to its unique features, we are kept safe from what would definitely kill us. However, once you step out of the planet, all bets are off, and the deeper in space you go, the more scary things you encounter. One of these things is a wormhole. A wormhole is both fascinating and scary, as you shall see. Thanks to their unending fascination, scientists have uncovered many things about wormholes and even created one. But what exactly is a wormhole? A wormhole is actually a solution to the equations describing Einstein's theory of general relativity, which connects two distant points in space or time via a tunnel. However, in this case, the tunnel's length is shorter than the distance between those 2 points, which means you can refer to wormholes as a shortcut between 2 points. For many years, wormholes have remained hypothetical, even though they have appeared in many sci-fi films, but of course, that is no longer the case with the recent discovery. You might have heard of wormholes referred to as Einstein-Rosen bridges. That is because the simplest possible wormhole solution was discovered by the great scientist Albert Einstein and Nathan Rosen in 1935. The duo started with the mathematical solution of a black hole, another terrifying phenomenon. A black hole consists of a singularity or a point of infinite density coupled with an event horizon, a region surrounding that singularity beyond which no object can escape. According to the physics of the universe, they found that they could extend the solution to include the polar opposite of black holes, white holes. These white holes also contain a singularity, however, they act in reverse to a black hole. They don't allow anything to enter their event horizon, and any material inside a white hole gets spitted out immediately. Now, this is where the wormhole comes in. Einstein and Rosen found that for every black hole in space, there is a white hole. However, because the two holes would exist in separate places in space, a tunnel would bridge the two ends. This tunnel is known as a wormhole. However, while wormholes can exist, there was a challenge: stability. A single photon or particle of light passing through the wormhole tunnel would introduce so much energy to the system that the tunnel would snap apart, destroying the wormhole. Also, if you have thought of a wormhole as a cozy secret passage you could take from one corner of the universe to another, you might be mistaken. Since you can only enter from the dark hole side, you would cross the event horizon and you would never be able to leave. This would mean you remain trapped in the corresponding wormhole for eternity. But scientists eventually found a way to make a stable wormhole and even make it traversable, meaning a mathematical equation or two will rescue you from being an eternal prisoner in said wormhole. The trick discovered in the 70s is to move the entrance of the wormhole tunnel beyond the event horizon of the black hole and to stabilize the tunnel itself so that matter passing through doesn't cause immediate catastrophic collapse. To stabilize a wormhole, scientists discovered you need what is called exotic matter, or some form of matter that has negative mass. Recent research found that a wormhole containing exotic matter could stay open and unchanging for longer periods of time. Negative mass is an interesting concept. For example, if you place an object with a negative mass beside a positive one, it will immediately accelerate even without any source of energy. Mind you, exotic matter is different from dark matter or antimatter. There is also the problem of size. Primordial wormholes are predicted to exist on microscopic levels, about 10 to 33 centimeters. However, as the universe expands, it is possible that some may have been stretched to larger sizes. But let's pretend you find yourself inside a wormhole. What will you see? Scientists discovered it would be strange. The entrance would be a sphere, like you are looking at the surface of a planet. If you looked into the wormhole, you would see light coming in from the other side. The wormhole tunnel could be any length, and while cruising down the tunnel, you would see distorted views of the region of the universe you came from and the region you were traveling to. In addition, wormholes can make a popular concept in movies a reality: time machines. How does this work? Let's start with special relativity, which says moving clocks run slowly. In other words, someone racing around at nearly the speed of light would not advance into their own future as quickly as someone standing still. So if you succeed in constructing a wormhole, initially the two ends would be synchronized in time, but if you accelerate one end to nearly the speed of light, that end would begin to lag behind the other end. The two entrances could then be brought together, but then one of the entrances would be in the past of the other. That may sound like a lot to take in, but if you want to travel back in time, you only have to walk through one end. By the time you exit the wormhole, you will be reveling in your own past, so you can literally relive some moments of your life. Meanwhile, with all this research into wormholes, we have not observed one in space, but a group of scientists took it upon themselves to create a wormhole in the lab. Should you freak out at this effort because of what may happen if things go wrong? These researchers based at the Autonomous University of Barcelona in Spain have designed a spherical device capable of transferring a magnetic field from one point in space to another. They said they were inspired by the theoretical work of Alan Greenleaf, a professor of mathematics at the University of Rochester in New York. Greenleaf came up with a theory for an electromagnetic wormhole that could transfer electromagnetic waves through an invisible tunnel between 2 points in space. However, Greenleaf's theory could not be tested for several reasons, but the Spanish team was able to use the magnetic metamaterials and metasurfaces to fashion out a wormhole that transfers the magnetic field from one point in space to another through a path that is magnetically undetectable. Creating the device was problematic as the materials needed were impractical and difficult to work with, but they did already exist, which made it easier to come by. One of the researchers, Jordi Prat-Cam, said they realized after extensive research that Greenleaf's concept could work. Building the wormhole took the team 4 months after they finalized the design. The overall effect is that of a magnetic field that appears to travel from one point to another through a dimension that lies outside the conventional 3 dimensions. The wormhole in this experiment is a sphere made of different layers, an external layer with a ferromagnetic surface, a second inner layer made of superconducting material, and a ferromagnetic sheet rolled into a cylinder that crosses the sphere from one end to the other. The sphere is made to be magnetically undetectable, invisible in magnetic field terms from the exterior. The magnetic wormhole is an analogy to gravitational ones as it changes the topology of space, as if the inner region has been magnetically erased from space. Meanwhile, these researchers had already built a magnetic fiber in the past. This was a device that could transport magnetic field from one end to the other. This fiber was, however, detectable magnetically, but the wormhole they have created now is a completely 3-dimensional device that is undetectable by any magnetic field. Interestingly, there is a practical application of what this Spanish team of scientists has built. Magnetic fields are used extensively in the medical field. For instance, the technology can help make patients comfortable during MRI scans by allowing them not to be close to the detectors. It can also help get MRI images of multiple parts of the body simultaneously. Meanwhile, scientists are still trying to unravel the truth about wormholes. But the question is, how can they prove that wormholes exist? Russian astronomers suggest that they may exist at the center of some very bright galaxies and propose some observations to find them. This is based on what would happen if matter coming out of one side of the wormhole collided with matter falling in. The calculations show that the crash would result in a spectacular display of gamma rays that we could try to observe with telescopes. This radiation can help to differentiate between a wormhole and a black hole. Scientists used to think the two were indistinguishable to an observer on the outside. However, black holes should produce fewer gamma rays and eject them in a jet, while radiation created via a wormhole would be confined to a giant sphere. Let's hear what you think of wormholes in the comment section below.